Alright, so today guys we are still going to be talking about polynomials. We're going to focus more on adding today. So this is going to be page 27 in our notes notebook, and it is going to be finding perimeter. Alright, so perimeter really only deals with adding, and that's when we add all exterior sides together. So that's how we're going to be finding perimeter today. So really we're just going to do a couple examples. This should be pretty quick and easy for you today. You will have one IXL lesson that requires you to find perimeter of a couple different shapes. You'll be looking at shapes anywhere from triangles to rectangles to probably pentagons and hexagons. Nothing too crazy though. So we're just going to go ahead and start off with a couple of examples. So we're looking at first a triangle. And you may run into something that has these two lines here, and if you remember this from last year, these do mean that they are the same length, or they have equivalent lengths. So if this over here is 2x plus 1, that means this one over here is 2x plus 1, even if they don't say that in the actual problem. And we'll put 4x minus 3 over here. So really we have three sides. Very first thing is if you do have a side that's not labeled, you want to go ahead and label it. So we'll go ahead and put 2x plus 1. And it's beneficial to go ahead and write all of this out. That's one way you could do it. So we're going to write out 2x plus 1. And I like to kind of check off as I go. Plus, because we're adding all of these sides together, another 2x plus 1. Plus, and then we're going to add 4x minus 3. All right, so once you've added all of your sides together, you'll just combine like terms. So we're looking at 2x plus 2x plus 4x. That's going to give us a total of 8x. And then we have plus 1, and minus 3. So that's going to give us 1, 2, minus 3 is going to give us negative 1. So our perimeter here is 8x minus 1. All right, second example we're going to do is a rectangle. And we're going to look at some properties of rectangles. Of course, mine's not drawn very well, but we know that opposite sides are equal in our rectangle. So if I know that this side is m, for instance, then I know also that this side is m, even if it's not told to me. So then up here we might have 6m plus 3. And again, we know that this side is also equal. So if you were just given a shape that looked like that, you would first want to go ahead and write in the different sides that you know. So we know if this side up here is 6m plus 3, that this side down here must be 6m plus 3. And if over here is m, then over here must be m, as long as we know it's a rectangle. And then we're going to write all of our sides out. So we have m plus 6m plus 3 plus m plus 6m plus 3. And then we're going to combine like terms. So we've got m plus 6m plus m plus 6m. So it's going to give us 1m plus 6m is 7m plus another 1m is going to be 8m plus 6m is going to give us 14m. So that's our first term, 14m. And then we have plus 3 gives us plus 6. There we go. All right, so for our next example here, we're going to do kind of an odd looking shape. So we're going to kind of draw almost like a house. That's an irregular pentagon here. And we can't really assume that anything is equal here. It doesn't have any of these congruency marks. It's not a traditional pentagon. We can't say all sides are equal. So we're going to go ahead and label these. I'm going to say this one is 2m plus 1 over here. We'll go ahead and call this 3m minus 2. This will be 4m plus 3. And we'll do negative 2m plus 10 and negative m plus 8. All right, so we got lots of different sides here. When we go to write this one out, it's going to be a little bit longer. So we definitely want to make sure that we leave enough room. So I'm going to start up here. I like to always go in kind of a clockwise motion. It helps me keep things straight. So I'm going to start with this one. We're going to have negative m plus 8 minus 2m plus 10 plus 3m minus 2 plus 4m plus 3. And then finally, we'll scoot it over. We're going to have plus 2m plus 1. And then we're going to combine our like terms. So we have negative m minus 2m plus 3m plus 4m plus 2m. Now it's always easier to start with your positive numbers, so I'm going to do that first. 3m plus 4m, 7m plus 2m is 9m. Minus 1 would be 8m, and then minus 2 more would be 6m. So our first term is 6m. This is a plus 8 here. Got to make sure we know that. So we're going to start with plus 8, plus 10, minus 2, plus 3, plus 1. So 8 plus 10 is 18, minus 2 is 16, plus 3 is 19, plus 1 is 20. So we have a positive 20 for our next term. All right. And the last one we're going to do, I'm going to throw in some exponents in here. And we're going to look at a shape. There we go, kind of an odd looking shape. And we have 1, 2, 3, 4, 5 different sides, so that tells us we're going to be adding 5 different polynomials together. So I'm going to start with x squared over here. This is going to be x plus 1. This one's going to be x squared minus 2x. Hey! So we've got x squared minus 2x here. We're going to have 3x here and just the number 4 right there. So we're still going to use the same process, just a little bit more complicated this time. We're going to start up here, and I'm going to start with x squared plus x plus 1 plus x squared minus 2x plus 3x. And finally, plus 4, and we're going to combine like terms here. So always want to start with your highest variable, or your highest degree, rather. So we have x squared plus x squared. That's actually going to give us 2x squared. It's like 1x squared plus 1x squared. Then we want to move on to our x's. So we've got plus x minus 2x plus 3x. So again, if you start with your positives, it's a little bit easier. 3x plus x is 4x, minus 2x is going to give us positive 2x. And lastly, we're going to have plus 1 plus 4 is going to give us plus 5. So our perimeter for this shape is represented by 2x squared plus 2x plus 5.